So this little video is just going to be a short demonstration of the InstaView technology that Tektronix have fitted to the AFG series, and they've done this to provide an alternative to using a scope on the output of your function generator, which would be the normal route. And so I have here a 1 meter cable, the standard default that comes with the AFG, and I've also got a 6 meter BNC lead there as well, to give a slightly different set of readings. Okay, so we'll just predominantly set up on the function generator to start with. To show the screen a little bit better, we'll swipe across to widen it, and we'll bring him up as well. I'm going to leave it at 1 megahertz, 1 volt peak to peak. So I need to turn on the InstaView, which is that button there, and you can only turn it on from this front panel and this button. As soon as it's turned on, it asks me I can do an auto measurement or a manual input. We'll do auto measurement. So from the InstaView, I want to run channel 1. Hit the run button, it tells me what to do. I'm already plugged in, so we'll go to the input on there, hit the OK button. And it does a couple of little tests, and you can see it's now giving me a number within the delay line. And then we'll unplug him, plug him in to the scope, turn channel 1 on, hit the OK button, and now there's InstaView. You can hear him clicking away to actually set up the InstaView reading, and you can see I've now got an amplitude reading 1.925 volts. So yeah, we're on a 1 meg ohm input on the scope, and I'm reading 1.96 volts peak to peak. I'm reading 1.925 volts peak to peak on InstaView, but you can also see the amplitude there is defaulted to 1 volt peak to peak, because the AFG is expecting a 50 ohm load. And you can swipe him up there, channel 1, you can see there the load is expecting to be 50 ohms, therefore with only having a 1 mega ohm input impedance on there, it's pushing out a higher voltage. So it's not shown on the setting, but it is picked up by InstaView. And if I change this now to 50 ohm termination, you can see, you can hear InstaView responding. I've now got 960 millivolts peak to peak on the scope, and 979 millivolts peak to peak on the function generator. And this InstaView works on square wave. We can put out, you can see it's there, I'm on 918, 996 millivolts. I get triangular 1.02, 936 millivolts. Pulse should still work. 0.962 against 980. I haven't got an arbitrary waveform loaded in there anyway, so we can see what. So I set them to 2 volts. It doesn't know that on the scope, does it? So I'm showing 1.995 there. The scope's only showing 80 millivolts. So I would hazard a guess. Okay, it's picking it up on the higher measurement is 2.02, and we've got against 1.9955. That's close enough. Okay, what I found, if I go to modulation, you get a little message up there that InstaView isn't supported. If I try and turn it on again, channel 1, turn it on. InstaView is not supported on modulation mode. You can turn it back to continuous, and what we will do, we'll just change him, and I'll show you what happens with a longer lead. So because I've changed the lead now, I would now need to run InstaView again. Channel 1, I run it this time, and you can see it's now come back with 30.99 nanoseconds, which is the longer lead. It's in here. We'll change him over, put him onto the channel, turn it on. Oh, okay, and we are 960 millivolts versus 1.004 volts on the sine wave. Let's go square. 980. It's fluctuating 960 and 980 millivolts, and 1.038 volts on the function generator. So it's close. It depends how accurate a measurement you want, but it does give you an alternative to having to have an oscilloscope on your output all the time. If your measurements don't need to be too accurate, then it could be a viable alternative, and obviously that's a much nicer alternative, just carrying this around than having to take both these two units with me. If you're working on a bench, then you're probably still better off going for an oscilloscope over trying to use InstaView.